Moving on with stratified squamous epithelium, this would be a lot of your skin cells. So stratified, lots of layers. You are thick-skinned. You don't want a thin layer protecting your whole body. Flat cells, so lots of layers of flat cells. And as you start at the bottom and move your way up, those cells are going to change a little bit. So type of tissue, layers of flat cells designed very much for protection. That's why there's so many layers. The shape of the top layer is used to name the type of stratified epithelial. So in this case, the top layer is squamous or flat. And the stratified squamous epithelial, outer layer of skin, it lines your mouth, your throat, vagina, and anal opening, any area that is subject to, like mouth, you eat food. Think of if your mouth did not have lots of layers. I mean, sometimes you bite the inside of your cheek anyway, but if your mouth did not have lots of layers, it would rip easily when you were eating food. Same thing with anal canal. It has to have lots of layers to protect as feces moves through it, or else it would have rips and tears when you went to the bathroom. So lots of layers, very protective. It protects against things getting into, getting out of, ripping, tearing, things like that. In the skin, outer layers undergo keratinization. What that means is basically that outer layer becomes a dry, waterproof protective layer. Basically, they're dead cells, the outer layer of your skin. However, this process doesn't occur where tissues are still moist. So like inside your throat, vaginal opening, things like that, keratinization does not happen there. In your skin cells, it very much is an important process. So what happens is, down here is where the new cells are produced, and as they age, they start to move up and outward. So as I move outward, basically these skin cells are going through that keratinization process, almost a dying process, which is why, same thing, if you scrape the outside of your skin, it really doesn't hurt. Those outside cells are pretty much dead. They're easy to flush off, which is why we lose them so quickly. Basement membrane is way down on the bottom. Note that it says layer of dividing cells. This is where new cells are produced. New cells are not produced at the top. So your skin is replenished at the bottom of those layers. Stratified cuboidal, so at least 2 or 3 layers of cube-shaped cells. Mammary glands, sweat glands, salivary glands, pancreas. A lot of these cuboidal cells are going to be in areas where something is secreted. So sweat glands secrete sweat. Mammary glands secrete milk. Several layers are going to provide more protection than if there was just one layer. And they function mostly with secretion. So here, the actual microscope slide over here comes from a salivary gland. So this is an actual microscope slide out of a salivary gland under your mouth. Here, see, there are layers. They are cube-shaped. So if I simply look at this diagram, I should be able to name that. Cube-shaped, more than one layer, so stratified, cuboidal. Basements at the bottom, free is at the top, like everything else. Stratified columnar. So lots of layers, column-shaped. This one's very rare. Basically, the place you're going to find this is the male urethra, Stretchy, it's going to allow for movement, in that case for urine, semen to move through. It allows a process or some stretching for those. So there's an example of stratified columnar. Notice they are longer on the outside. They're a little bit shorter as you get towards the bottom. Almost has a cuboidal shape at the top or at the bottom. But remember, when you have a stratified layer, it's named after whatever's found at the top. So this column shape is going to give it that name. Transitional, here's another type of tissue, very stretchy. So transitional epithelium allows things to distend and stretch. So urinary bladder, male and female bladder. Urethra, ureters. Ureters are the tubes that go from your kidney to your bladder. This design allows them to distend, they're stretchy, and then keep coming back to its normal shape. It keeps urine from diffusing back into the cavity. Transitional is going to have layers. We don't want this to be single-celled, or else stuff would transfer through it too easily. So there's a couple of examples. You can see, so this is transitional epithelial in its normal position, lots of layers. As I fill my bladder and my bladder starts to stretch, it stretches them out and makes that layer look thinner because it has stretched it out. Glandular epithelial, typically cuboidal, probably even more so columnar. They're designed to secrete something. Here, circle, make sure you highlight this one. Glands that secrete into a duct are called exocrine. So when they release something, it's going to go through ductwork. It's going to go through a duct. Those that secrete directly into body fluids, so they don't have ductwork, are called endocrine. So endocrine glands, you probably hear a lot about. Exocrine, you don't hear that term as much. Exocrine into a gland, endocrine into blood and body fluids. So we're going to look at different types of these. Merocrine glands release fluid by exocytosis. Exo means outside. Cyto means cell. So I'm going to release something outside of a cell. So pancreas, salivary, sweat glands. Some are serous. Here's another thing you want to know the difference between. Serous means watery fluid. It's very thin, low viscosity, runny. So serous, watery fluid, lots of enzymes typically in it. Mucus is a thicker, higher viscosity protective substance. So serous, watery, mucus, thicker. Apocrine glands pinch off a portion of their cell. That would be a mammary gland. So when milk is produced in the mammary glands, it's actually a part of that cell that produces or makes the milk. This can be pronounced holocrine or holocrine. I pronounce it holocrine to remind me that the whole cell is released. So holocrine is going to release an entire cell. That cell kind of disintegrates and produces typically some type of oil. So sebaceous glands, sweaty, oily, it's going to produce sometimes a smelly oil like armpit sweat would be an example. it's going to produce an oily secretion. So here is a picture of those. So saliva, American gland. It simply releases substances out of the cell. I have little pieces inside of my cell, the saliva, here's a packet of it. That is going to be released from the cell. It secretes something from inside. Apocrine gland, a part of the cell breaks off. So a part of the cell actually is broken off, and that's going to form whatever secretion, in this case it would be milk. It's going to form whatever is least. Holocrine, I'm going to simply release a whole cell, a new one comes in, this one leaves, it disintegrates and it produces an oil, which you can see sometimes is going to block an opening that it comes out of, and you can get pimples, things like that. But holocrine, you lose the whole cell is lost. So that's kind of my ways of remembering. Apo, a part, holo, whole cell. And then this table again, good one to look at towards the end and review, as these are all the different types of epithelial cells. And that is where we'll stop for today.